In this short video, we will see most of the commonly used tools such as an open-end diesel hammer, swinging leads, pre-stressed concrete piles, templates, and an auger, all pieces of equipment in the driving of piles in Florida. This video has been produced for use with the Pile Driving Inspection Qualification class for the Florida Department of Transportation's Construction Training Qualification Program, or CTQP. Our first view is of a hammer on the ground. The inspector should verify that the hammer is the one that has been approved for the project as shown in the contractor's pile installation plan. We see the hammer on the ground, but in the leads, this is an open-end diesel hammer, the most commonly used hammer in Florida. Each hammer should be equipped with the manufacturer's label indicating the hammer make, model, serial number, maximum stroke height, and other information. The contractor uses templates with swinging or semi-fixed leads. In this video, the contractor has swinging leads, which are the most common in Florida. The template should be rigid and fixed so that it securely holds the pile in its proper alignment. It is frequently used as the reference for the driving event. As illustrated in this template, most are constructed of steel elements. Also common are timber inserts, which are less likely to damage the pile during driving. Concrete piles, as shown here, are the most common pile type used in Florida. Once piles have been delivered to the job site, it is the inspector's responsibility to observe the contractor's handling and marking of the pile prior to driving. The inspector is also to ensure that the piles were intended for this project and are of the expected size and length. There should be marking on each pile from the casting yard indicating the yard's acceptance for transport. In this instance, there is blue lettering on the pile that indicates CQC acceptance for transport. As illustrated here, the contractor will mark the pile in 1-foot increments. This contractor is using spray paint, a common method, to mark the pile with the numbers every 5 feet. This is one of the several methods that contractors use. Advantages of this one are that the marks can be seen from greater distances, but the marks are about 2 inches wide, making the actual mark difficult to discern well. Shown here are plywood cushions. The plywood cushions are made from standard plywood sheets and are cut to fit the helmet. They are usually nailed together and are frequently made into 3 or 4 inch thicknesses to ease lifting and handling. Also pictured here is one of the sexometer models available. It is a good idea to familiarize yourself with its operation prior to driving and to verify its accuracy during the test pile program. The operation being shown now is associated with augering a hole that the pile will later be set into. The leads used for the auger process in this instance are very similar to the pile driving leads. As we watch, the contractor is lifting, setting, and beginning to drill. There are 2 operations within our standard specifications under which the contractor could use this operation. One is pre-drilling, the other is preforming. These are important distinctions for the inspector. Pre-drilling is an operation for which the contractor is not paid. Preforming, on the other hand, is compensated. The 2 operations look almost identical. During this class, we will explain the differences between pre-drilling and preforming. How we measure and report these items can be important, and we will learn how to report these in notes and pay in the Pile Drive program. From the drilling, we move into the part where the contractor is preparing to lift the pile and place it into the template. Take note during the lifting of the pile of the number of lifting points along with where they are located. Part of this course will show the inspector how to determine any and where these lifting points should be. Lifting and handling of the pile prior to driving can be the source of breakage in the concrete piles even before it is driven, so care is important. After the pile is vertical, it is lowered into position. Notice the contractor is using wood blocks to assist with alignment procedure. Using wood blocks in contact with the concrete pile, cushioning against damage from the template steel, contractors can reduce the possibility of damaging the exterior face of the concrete. The pile cushions seen earlier are now being inserted into the helmet. Note the use of the cable on top of the plywood cushion. The purpose of this cable is to permit the easy removal of the pile cushion after driving. Now that the new pile cushion has been inserted, the hammer is to be placed on top of the pile. Note the care taken to align the hammer and pile and to place the helmet over the pile. The contractor is lowering the line to engage the pawl, which will lift the ram and initiate the operation of the hammer. Once the pawl is engaged, the ram is raised and dropped, starting the pile driving. We are now watching the pile driving operation. Note the hammer operation, the marks on the pile, the smoke from the hammer. The hammer is now running as evidenced by the visual of the ram at the top of the cylinder. Operation of this open-end diesel hammer is controlled by a hydraulic control mechanism as shown here. As the course progresses, we will discuss the ways that diesel hammers are operated. Note as the hammer continues to run, the ram is clearly visible as the top of the ram comes out of the top of the hammer. The inspector is using a saxometer to view the ram strokes. Note that the readings shown at this point are not correct. Note the position of the saxometer on the concrete barrier wall. During the course, we will discuss the use of the saxometer and what its limitations can be. While watching the saxometer, note the changes of the stroke height with each impact and that the saxometer continues to count with each stroke. Watch now as this pile is driven from 34 to 35 feet below the template. At each impact of the hammer, the pile is driven into the ground. However, with each impact, the pile also moves upward slightly when the ram releases. This is known as rebound. Also, as this foot is driven, note that the contractor checks the plumbness of the pile using a level. Also note the contractor's use of safety lines when walking on the template. Each project will be set up differently, but safety is always, at the very least, a personal issue. The pile is now at 50 feet. As the pile passes this point, note the two epoxied marks on the pile. These are the remains of the lifting eyes that were used in the casting yard to remove it from its form. It is required by the specification that these eyes are removed and epoxied at the casting yard. Notice the template, the pile in the template, the leads and the hammer in the leads. And note that the hammer is running. As the pile continues to be driven in the ground, we observe it to be going from 64 to 65 feet below the template. Note the relatively rhythmic operation of the hammer. It is important to know that while the ear does not give a number, it is a very sensitive instrument that can notice change in operation. It is not our responsibility to fix problems, but we should be able to recognize that the hammer is no longer operating properly and therefore, we as the inspector cannot accept the pile. As the pile approaches the 78-foot mark, note the damage on the pile. Part of this course will describe what we, as the inspectors, are to do in this circumstance. The pile has now met the driving criteria, and the inspector accepts the pile, and the contractor shuts down the hammer. All that is left now is the post-driving information collection. The contractor will need to shoot a top-of-pile elevation to establish the final tip elevation, and also mark the cutoff elevation, but it is not usually done until all the piles in the bent or pier are driven.